the last video we have learned about potential energy. Now let us see what is gravitational potential energy. Now when a body, consider a stone or water, is raised at a height above the ground, then the work done against moving the body to a height is stored in the form of gravitational potential energy in the body. Therefore, the potential energy of a body at a height is the amount of the work done against moving it in the upward direction against the force of gravity. So now let us derive the equation for gravitational potential energy. Now if I consider a body of mass, okay, m kgs, right? If I consider a body of mass m kg and it is moved from the ground level to a height, that is the distance moved above the ground level to a height of h meters. Now the minimum force required to move the body at a particular height will be equal to the force of gravity which is acting on the body in the downward direction, right? Therefore the force of gravity is denoted by G, right? Force of gravity is denoted by G. Now if this gravity acts on the mass of 1 kg, right? So if the same gravity is acting on the mass of m kg, then the force will be given by, the force acting on it will be given by mg newtons, right? It is given by mg newtons, and the distance moved, is given by, that is h meters. Now we know that work done, is equal to force into distance moved. Therefore F is equal to mg into h. So this is the equation for the gravitational potential energy. Since the work done, now what is gravitational potential energy? It is the amount of work done in moving the object to a particular height against the force of gravity, so which is denoted by mgh. The SI unit of potential energy is joules. Now we see that the dependence of potential energy, which is when an object is raised to a particular height, the potential energy depends on two factors. First one is the mass of the body and the second is the height from the ground. Okay, so first factor is, that is the mass of body, and the second factor is the height from the ground, level. Okay, so now we see the first factor. So greater the mass of the body, greater is the potential energy. Now I take an example over here. Suppose the potential energy of a bucket of water of 10 kgs, okay, on the first floor, and will be more than the bucket of water of mass 5 kg on the same floor. So more the mass, more is the potential energy. Now we see the second factor, that is height from the ground level, the height at which it is raised, right? Now if I consider a bucket of water of mass 10 kg which is on the second floor, that is at a height of 6 meters, and I consider a bucket of water of mass 10 kgs which is on the first floor at a height of 3 meters. So in the first case the potential energy will be more as it is raised to a more height than in the second case. So these were the two examples of the gravitational potential energy. That is, the potential energy depends on the two factors, mass of the body and the height from the ground. We start with kinetic energy. We see what is kinetic energy. Now basically kinetic energy is denoted by the symbol, that is capital K E, or it is denoted by K. Okay, it is denoted by kinetic energy or capital Ke or K. Now what is kinetic energy? Kinetic energy is the energy possessed by a body due to its state of motion. Okay, so kinetic energy is the energy possessed by a body due to its state of motion. Now to understand kinetic energy, we take two examples. Now first example is of a stone striking a window pane, a glass window pane. So when a moving stone strikes a glass window pane, it has the capacity to break the window pane. So from this we understand that the moving stone possesses kinetic energy, right? Another example we take of a hammer. Now when we use a hammer, so while striking a hammer on a nail which is fixed on a wooden block, when we strike a hammer on the nail, we observe that the nail further penetrates into the wooden block. So the moving hammer also possesses kinetic energy. Some more few examples of kinetic energy are, now a bullet fired from a gun, right? When a bullet is fired from a gun, it possesses kinetic energy. A moving bullet possesses kinetic energy. Next example is an apple falling from a tree which is in motion, so it possesses kinetic energy. Other examples are a rolling ball, flying birds, then we have blowing wind, swinging pendulum and flowing water. All these examples are of kinetic energy since the body is in motion. Now, if we consider a body which is initially at rest and we tend to move the body. So, in moving the body, when the body is in motion, it possesses kinetic energy. Now, this kinetic energy is equal to the work done on the body. Now, further we will see the factors which affects the kinetic energy. Okay, the factors on which the kinetic energy depends. Now, kinetic energy depends on the first factor, that is, we have the mass of a body. Okay, mass of the body, and second factor is the speed of the body. Speed of the body. So we shall see the factors on which the kinetic energy depends. Now the first factor is the mass of the body. Now to understand this, we consider an example. Now, greater the mass of the body, more is the kinetic energy. We take an example of a body in motion. Now a body, if a body is moving with a mass of 10 kg, okay, with some speed, and we consider another body of mass 5 kg which is moving with the same speed, we observe that the kinetic energy possessed by the body having more mass will be more than the body possessing less mass. Okay. Next is kinetic energy also depends on the speed of the body, right? Now, if a boy moves with a speed of 2 meters per second, okay, and afterwards he changes his speeds to 4 meters per second. Now, when he changes his speed from 2 meters per second to 4 meters per second, you will observe that the kinetic energy becomes 4 times than the kinetic energy in the initial state. Okay, so in the first case, the kinetic energy will be less, and in the second case, that is for when he increases his speed to 4 meters per second, the kinetic energy becomes 4 times. So this tells you that more the speed of the body, more is the kinetic energy. Now, moving on to kinetic energy, the equation for the kinetic energy. Now, suppose if we consider a body of mass m, Okay, so a body of mass m, and moving with a speed, it is moving with a speed v, then kinetic energy is given by half mv square. So this is the equation for kinetic energy, that is half mv square. This equation is very important for solving the problems and you should know this equation. Now we have already studied the equation for kinetic energy. So now we see the unit for kinetic energy. Now the unit for kinetic energy is joules. Okay, so the unit for kinetic energy is joules and it is given by the symbol J. Now further we see the dependence of kinetic energy on speed. Okay, so to understand the dependence of kinetic energy on speed, we take two examples over here. Now the first example we take a carom board and we place the coins in the middle of the carom board. Now you will observe that if the striker is being hit with little efforts, it covers small, the coins which it strikes covers small distance. But if the striker is hit with more efforts, right? If it is hit with more efforts, the striker gains more kinetic energy. So more the kinetic energy, the coin which it strikes will move with more distance. It will cover more distance, right? So more the kinetic energy, more is the distance covered. Now next example we see. Now when we watch a cricket match, right? If the batsman strikes the ball with little efforts, the ball will cover a shorter distance. But he strikes the ball with more efforts. That if he strikes hard, the ball will cover more distance to fetch him a 4 or 6 runs. So these were the two examples of dependence of kinetic energy on speed.